Hey guys, so continuing our discussion on ray diagrams, let's focus now on lenses. Starting with convex lens, which of course, if you remember, the convex shape is outward. We'll put our object over here, but even if our object was over here, a lens can go both ways. So I'll draw that with a different color to show the other side of the lens. So this one will go this way, and this one in that direction. Of course, the direction of curvature tells where the focus is, so we have one of the foci of the lens on this side. But of course, we have another focus on this side. So if the light's coming from the left, it will converge to the right, and if the light's coming from the right, it will converge to the left focus. Of course, this is a converging lens. So if we have our object here, once again we draw the object from the middle line, the meridian. And let's see what image we get. Once again, we want to draw 3 lines. After the lines intersect with the lens, they will be refracted and create a new line that extends forward and backward to infinity. Where those lines converge is where the image is. Of course, they converge at the image tip because we're looking at the origin being the tip of the object. So these lines will be the exact same, essentially, as the lines as we saw for mirrors. Except one key difference. First of all, the light goes through the lens. I guess 2 key differences. It goes through the lens. The other key difference is instead of bouncing off the middle, we're going to see the third actually goes straight through the middle as if it's a plane lens, which of course, as we saw in class, is a window. But that ends up usually being the check. It depends on which ones you like. It really doesn't matter which of the 3 you draw, as long as you have 2 of them, and the third ends up being your affirmation, so to speak. So the first is the same. Light that goes in parallel, of course, as we know, this is the whole point of mirrors and lenses, ends up going through the focus. And of course, you only worry about what happens after it engages with the lens. So let's draw a straight line in, and then I'll draw a line through the focus. Extending it back, I like the dotted line representing the imaginary, because if it extends and these 3 lines converge at the imaginary, remember, if they're virtual, that means they have to connect in the virtual realm. So they have to connect imaginarily. What that means is that if we have to connect these in the virtual realm, I doubt this one will be that example, but I'm certain the next one will be. If we have to connect them with these imaginary dotted lines, we know it will be upright and we know it will be virtual. So this will also be always upright. The second is through the focus, out parallel. Be careful here, guys. You're going through this focus now because you can imagine a parallel line. Remember, this is always the backwards, moving in reverse. So here's how I remember this one. Imagine light coming from the other direction. It will go through the focus. So you want to reverse that. Light going through this focus goes parallel. Did you find it? Well, we could have extended this one a little more. They connect. Okay. Don't be impatient. If they don't actually connect here, draw it a little farther. And that's where they'll connect. Notice it is upside down. It's inverted, which means it's real. How else do you know it's real? Think for a second. Did they connect imaginarily? No. The actual light rays connected here, which means there literally are photons here. So it's a real image. Real is always inverted, virtual is always upright. We can always check the third option, which is a light ray that goes directly through the middle. As we see, that is confirmed to intersect the same place that these lines did. Perfect. Let's try concave. Remember, concave is the cave shape. But a lens has two, right? Because you can use it from either direction. So this shape will have a focus on this side, a virtual, imaginary focus, because the light goes through the lens and connects back here imaginarily. And of course we will have this focus on this side. Looks like an hourglass shape. This will diverge the light such that if we have an object somewhere over here, light that goes in parallel will pass through the focus, but imaginarily, because it has to go through a lens. And as you'll do for homework, you'll show how it intersects with this boundary and this boundary. Notice I'm not worried about those details because I know the net result is a divergent ray that extends back to the focus. You can almost say like it hits the middle of the lens and then moves out. Notice I did the same here. You can simplify the ray diagram. You don't have to do the individual refraction rays like you're doing in homework. Though I do want you to do it for the homework just to prove that it does indeed diverge. Cool. So through the focus parallel, you are going to have to make it go through this focus now, and it will come out parallel. Because if you imagine it coming back in this way, it would extend backwards like that. So that's going to be a little tricky. So I'm just going to go directly through the middle. I typically do that with these concave lenses. Notice how it connects right there. Notice how if we did draw the line through the focus here, it would go out parallel. And we could imaginarily draw it back there. I should have made this line a dotted line. Maybe I'll show the dotted lines of imaginary connection in pink. Meaning these 3 light rays are the real light rays that the lens is causing. Parallel through the focus, through this focus, parallel, and directly through. Notice they all connect at the same place, right here. And if you, of course, have our meridian line, don't forget to always pay attention to that. You will notice that we get an image right there. There's our image. Is it real or is it virtual? 2 ways to know. If it's upright, it's virtual. And if it's connected imaginarily through the imaginary lines backward, it means you're only going to see it imaginarily. Which means your eyeballs, wherever your eyeball is, if it's here, 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 the point is that you're going to imaginarily see it here as if you're not going to see this one. If your eyeball is on this side of the lens, you're only going to see this one. Whereas to see this one, you actually are going to have to collect this light with a screen or a retina, right? Some physical object is going to have to actually intersect these photons for it to actually appear real. Notice that your retina does collect a real image and flips it. I don't know if you guys knew that. We can talk about that more in class. I think that's it. You guys have a great weekend.